All right, hey there, everybody. Here we are, week 6, complex numbers and some math induction. One of my favorites, love it. I'd like to start with problem number 1 today, so let's get it going here. All right, so with 1a, 2 marks, this expression here, cosine pi over 3 plus I sine pi over 3, is equivalent to cis pi over 3. Okay, if I were to cube that, instead of expanding the expression above using the binomial theorem, I can use de Moivre's theorem, which tells me that I would have 1 cubed cis 3 times pi over 3. Okay, and this 3 right here, using de Moivre's theorem, is that 3. So I would have, it looks like 1 cis pi. And that will be equivalent to -1. So let me explain a little bit. So cis pi is polar form for a complex number. So that means I'm going to extend the modulus, which is 1. So I extend out 1 unit out to here, and then I rotate pi radians, which brings me over here to -1. Okay, so there you have it. Using de Moivre's theorem, we found the value of cosine pi over 3 plus I sine pi over 3 to the third. Part B, we're going to use a little math induction to prove the following is true. All right, so in step 1, we use, it looks like n and z plus, so our first available n will be n equals 1. So we're going to prove that cosine theta minus I sine theta to the first is equal to cosine of 1 theta, right, because that's n, minus I sine of 1 theta. Not a whole lot to do here, because this will come out to be exactly that. If I take this to the first power, it becomes the following. So we get cosine theta minus I sine theta is equal to cosine of 1 theta minus I sine of 1 theta. And it checks. Part 2, that's basically a free mark, likely. We're going to use the assumption that this works for n equals k. Therefore, cosine of theta minus I sine of theta to the k power is equal to cosine of k theta minus I sine of k theta. Now this is the assumption step, so we're going to assume that this is true. And we're going to use it in step 3. And we're going to prove that cosine of theta minus I sine of theta to the k plus 1 is equal to cosine of the k plus 1 theta, minus I sine of k plus 1 theta. We got to prove that's true. Okay, so the first step to doing this is to somehow expose this expression, because then we can use this and we can work from there. So what I'm going to do is I'm going to rewrite this as cosine of theta minus I sine of theta to the k power times cosine of theta minus I sine of theta to the first. Okay, now look at that. I've got what I want here. I'm going to replace that with cosine of k theta minus I sine of k theta. And then just duplicate this, cosine theta minus I sine theta. Alright, I'm going to expand that now. So that would be cosine of k theta cosine of theta minus I sine theta cosine of k theta, okay, minus I sine k theta, cosine theta, and then last, that'll be plus I squared, so minus sine k theta sine theta. All right, now I'm going to underline a couple of things here. I'm going to underline cosine k theta cosine theta minus sine k theta sine theta. And what that is ends up being cosine of k theta plus theta. Okay, cosine of k theta plus theta, right? Because if I expanded that, I'd get cosine k theta cosine theta minus sine k theta sine theta. All right, and then in this component, I get two imaginaries. I'm going to go minus I, and then sine theta cosine theta, sine theta cosine k theta, sine k theta cosine theta is sine of k theta plus theta. Now we are almost where we want to be. Of course, we wanted to show this, so we can factor out a theta in both of these terms. So it'd be cosine theta, k plus 1 theta minus I sine k plus 1 theta. And there you have it. So we have to write a statement. Since true for n equals 1 and n equals k plus 1, then true for n in z plus. Awesome. There you have it. That's a little de Moivre's theorem and some math induction. I think I'm going to try one more part to this problem, and then we'll probably end this video at that point. Let's see what we got next. All right, 2 marks. We should probably be able to get that in the next couple minutes. Let z equal cosine theta plus I sine theta. Find an expression in terms of theta for z to the nth theta plus z star. Z star is the conjugate of z and theta, where z star, of course, there it is the complex conjugate of z. All right, so what I'm going to do is I'm going to write this as z equals cis theta. Okay, so z to the nth would equal cis n theta using de Moivre's. Z star to the nth would equal cis negative theta to the nth. Okay, so z to the nth would equal, like I said, cis n theta. Z star to the nth, would equal cis negative n theta. Okay, so I'm going to expand these right quick here. This would be cosine n theta plus I sine n theta. And this would be cosine will actually be n theta, and I'll explain why, minus sine n theta in just a second here. I'll explain. So if I added these two together, what I would get for z to the nth plus z star to the nth, you would see the imaginary components cancel, and so what we'd end up with is 2 cosine n theta. Okay, so explanation here. This would really be negative, and that would be positive, and that'd be negative, right? If you use de Moivre's and you expanded it all. But since cosine is an even function and sine is an odd function, then the negative on the inside of the cosine just negates, and we get cosine n theta because it's an even function. And because sine is odd, I bring the negative out in front. So it's the opposite of the function itself. Therefore, here we go. We get this expression for z to the nth plus z star to the nth. All right. Yeah, I think I'm going to wait on D and E for the next video. So I hope that made sense. Shoot me some questions if you got